Day 20, race condition. The historians are quite pixelated again. This time, a massive black building looms over you. You're right outside the CPU. Ooh, here we go. While the historians get to work, a nearby program sees that you're idle and challenges you to a race. Apparently, you've arrived just in time for the frequently held race condition festival. Oh, that's cute. The race takes place in a particularly long and twisting code path. Programs compete to see who can finish in the fewest picoseconds. Cool. The winner even gets their own mutex. Neat. Awesome. They hand you a map of the racetrack, your puzzle input, for example, this. Okay. The map consists of track. Okay, so period is the track, including the start, S, E for end, and walls as a hash mark. Okay, fine. Like, we know all this. Cool. When a program runs through the racetrack, it starts at the start position, then it is allowed to move up, down, left, or right. Each such move takes 1 picosecond. Okay, cool. The goal is to reach the end position as quickly as possible. In this example racetrack, the fastest time is 84 picoseconds. Okay, so this is just like solve the maze and get there as quick as possible. Nice, easy. Because there's only one single path from the start to... Hold on. There's only one single path? Oh, yeah, look at this. Oh, my God. This isn't even like... I mean, like, we're going to have to solve the maze, but we're just going to have to figure out the direction. There's no actual, like, solving here. Oh, so... okay, I'm thinking ahead. Our algorithm is bread first? Yeah, we're going bread first. We're trying to find bread for Bashcop. When we find her bread, the problem is that if there's only one path, we don't need that. We can just do depth first because we'll just automatically get on the right path. Yeah, I'm looking at this example. There literally is only... I'm just snaking around it. There's only one path. Okay, cool. Easy. Because there is a single path from the start to the end and the programs all go the same speed, the races used to be pretty boring. Well, yeah, I'd imagine. To make things more interesting, they introduced a new rule of races. Programs are allowed to cheat. Sick. That's awesome. The rules for cheating are very strict. The rules for cheating. All right. Exactly once during a race, a program may disable collision for up to 2 picoseconds. Interesting. I'm scared. This allows the program to pass through walls as if they were regular track. At the end of the cheat, the program must be back on normal track again, otherwise it will receive a seg fault and get disqualified. Okay, cool. Program could complete the course in 72 picoseconds, saving 12 picoseconds. Oh, because the original fastest one was 84. Okay. By cheating for the 2 moves marked 1 and 2. Okay, so the moves are down here. If we go up here, okay, it's a wall and a track. So I'm assuming the wall is 1 and they step through it. So this is the first step and this is the second step. So they've just, they skipped over this much track. Okay. And the amount they skipped over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This saves 12 picoseconds. Oh, I guess because it technically still has to walk through here. So it's 3, I counted 15, the 3, subtract the 2, you get 12. So they skip 12 blocks. Okay, cool. This all makes sense. Or a program could complete the course in 64 picoseconds, saving 20 by cheating the 2 moves marked 1 and 2. Okay, cool. This cheat saves 38. Awesome. So we just have 1 and 2. The place that we started, and 2 is the wall that we are colliding through. Or not colliding through, actually. Each cheat has a distinct start position, right? The place that we're starting. The position where the cheat is activated just before the first move that is allowed to go through walls. Right, so yeah, in these examples, 1... where's that first example? 1 is... Wait, no. Hold on. 1 is a wall. Okay, so in these examples, 1 is the wall and 2 is the final place that it ends up? She's a distinct start position, the position where the cheat is activated. Where is it activated? In the wall? That wouldn't make sense. It would have to be activated before the wall. Just before the first move that is allowed to go through walls. And an end position, cheats are uniquely identified by their start position and end position. So, okay, if I'm reading this correctly, then what they're showing me here in the examples, this is not the start and end position. 2 is the end position, but the start position would actually be here, if I'm reading this correctly. This is the wall that it glossed over. So if this is the start position and this is the end position, that's how you would uniquely identify the cheat, by this coordinate and this coordinate. The problem is, I don't think this uniquely identifies a cheat, because, like... I could imagine a start position and end position that you could clip through 2 different walls to get there. Like, okay, like, picture a diagonal. If you have, like, a thing here, and above it is a wall, and like over here is a wall. Like, if you go like this, down to the right, you've gone through a wall. And if you go here, right and then down, you go through a wall. So you went through 2 different walls, but the cheat would technically be the same because the start and end position is the same. It's like you're clipping through diagonally. I don't know. I'd have to. I might be misunderstanding this, but I'm gonna go with what I think is it. The start, because they use numbers here to illustrate it, but they never explicitly said anything about these numbers that would lead me to believe the start and the end position. They're just describing right here. Each cheat has a distinct start position, the position where the cheat is activated just before the first move that is allowed to go through walls, and an end position. This I would take to be where you ended up after you went through the wall. So the wall itself is not considered in the unique identifier for the cheat. So if we had 2 walls that we could clip through that were at the same start position, at the same end position, I guess they'd finish the race at the same time, and we would just count that as one cheat. So whether they went, right and then down, or they went down and then right, it doesn't matter. That's how I'm interpreting this. I don't know if that's correct. We'll see. In this example, the total number of cheats grouped by the amount of time they save are as follows. Okay. There are 14 cheats that save 2. There are 14. Okay. You aren't sure what the conditions of the racetrack will be like. So to give yourself as many options as possible, you'll need a list of the best cheats. How many cheats would save you at least 100 picoseconds? Okay, so we have to take the maze input, solve it, figure out how many picoseconds it took, or how many steps we took, because 1 step is 1 picosecond, and we're not going to be backtracking or anything. Find that out, subtract 100 from it, and then find all of the solutions that are equal to that or less. Okay. I at least have a starting point for this. Yeah, I guess let's pop open the terminal. Let's get started. Where are we? Day 19. Cool. Make dir day 20. Dark space. I'm interested to see what your joke's about now. I'm interested to see how it comes up. All right, so we're in day 20. Example input.text. I'm going to grab this from the website. This is just the maze they gave us as an example. Easy peasy. Where did we solve a maze? The reindeer one, right? Was that day 18? I think it was. I'll go steal that from day 18. The real input, I will not share that. The real puzzle input, of course, is gigantic. As always. Okay. I think it's day 21. Oh, okay. Well, I'm still excited because I'm going to get there. I'm going through all these. Okay. Let's remember where we solved a maze. I think it was day 18. Yes, it was. So we have our maze solving algorithm that we use BFS to solve. So what I will do is I will vim day 20 part 1, day 18 part 1. Cool, and we will just steal some of this stuff from it. So we'll steal the grid what am I doing? Why don't we just take it all, huh? Day 18 part 1, let's move that to day 20 part 1. Cool. Now we're in day 20 part 1. Let's go through and clean this up. We make our grid. We have a print grid. That's awesome. Initialize the grid is all free. This is not right. We have a solve the maze. Okay. How do you like NeoVim? I have no idea. I don't use NeoVim. I'm using just regular Vim. So I can't really speak to NeoVim. Let's read the maze. Okay. While read -r line do done. Width equals the length of the line. Height equals 0 all the way at the bottom here. Height plus plus. We've written this 8,000 times. For x equals 0, x less than the width of the line. Oh no, just width. Yeah. X plus plus, do, done. Key equals x comma height, and then we can say grid key equals whatever the character was at that location. So the C at line spot X substring to 1 location. Cool. So now we have to do some checking, actually. Case C in dot. If it's a dot, then we do nothing. If it's a wall, then we do nothing. If it's the capital letter S, then we mark the start location as the key, and we set the key equal to a free space, because our start location is technically a free space. Oh, hey, what's up, Ash? How you doing? And if this is a capital E, then this is our end location. I'm not going to bother putting error checking around this because, or input validation, because the mazes that Eric creates are always seem to be valid. Like, this is not a puzzle on trip you up with invalid input. It's a brain puzzle, which is a lot of fun. Cool. So now that we're here, we can say echo maze is width by height, echo start location equals start loc, and end location equals end loc, and then we'll print the grid, and then we'll call exit. This is just to make sure that we have read everything in correctly. Part 1, read in from example input. And cool, maze is 15 by 15, start location is 1, 3, and the end location is 5, 7. I mean, that's probably right? Yeah, that looks good. You know what we could do? I've been thinking about doing this for a while, and I just haven't. In our print grid function, we can do something like amazing that I hadn't thought of, and I don't know why I hadn't thought of them. But we can use colors. Like, we could say like I don't know, red equals tput set af1, and then reset equals tput sgr0, and then we can do something like this, like if C equals a wall, then C equals red, the wall character, yeah, and then reset. We could do something like that. So then when we print this actual maze, like, I mean, I don't know if that's like cool or not, but like we could make the maze a little bit nicer. Yeah, if it's a free space, we could make it dim. And if it's a wall, we could make it, yeah, I guess we'll just leave it as red. We could literally do this amazing. That's so true. Like, we could do this. I guess it doesn't make sense to make it dim if we just did, yeah, I don't know. I don't know if that's helpful or not. Yeah, the dim doesn't make any sense if we're, not printing a character there. I mean, that's kind of nice. Looks like a nice little Pac-Man board. I don't know if that'll be helpful or not, but it was still just a cute thing I had thought of. Okay, so we read it in. We have the start location and the end location. And then in order to do this, we are not going to use breadth first. We will use depth first. So I wonder if recursion makes more sense. Or when we pop off the queue, we pop it off at 0. We could just pop off the end technically. That might make more sense. Let me figure out how this works. If I have an array in bash, and then we, plus equal foo bar, that doesn't work. Array equals foo bar baz. Howdy bashers. Yo, what's up, Matt? How you doing, man? If I take the array at -1, this should be baz. Okay. if we unset, let's see, do I have fired up? No, I have PR. If we do this, that's what it looks like. Okay, if we unset array -1, it's gone. So now if we push to it, what do we have? Okay, it sets it back as 2. Okay, we can just take off the end of the list and then we just change it to depth first. It's not a big deal. It doesn't even matter. Breadth first technically works. It'll just be slightly slower. Yeah, instead of doing this, we could just do this. There we go. So now we're going to solve the maze. Okay. I think we can just run this against the input and let's see what happens. I have the exit in there, so let's go ahead and remove that. Maze is unsolvable. That can't be right. Well, yeah. It's because we keep passing along the steps. Okay, it takes 84 steps to beat the maze. Okay, so we beat the maze. Cool. So we can solve the maze. And we can tell you that it takes 84 steps to beat it. And that sounds right, because if you look at this, the fastest time is 84 picoseconds. So we nailed it. Cool. That's not the question, is it? Oh, man. The question is, we have to go through and create the cheats now. So how are we going to cheat? Let me think about a couple solutions to this. I have a lot of ideas. So, well, look at this. If we want to cheat, like for example, we want to cheat through this wall, we would start here and we would end here. And this is important because this is our unique key, our start and our end. And if we were to do this, we were to skip all this stuff. We would skip those 5 steps. So once we get here, if we started, so let's imagine this. Let's imagine we move this hash mark and then we solve the maze without it. We would get down here and we would be faster. But we don't, we could do this. We could just remove the pound signs everywhere. Go brute force solution, remove the pound signs one by one, solve the maze, and then figure out which one is, figure out the time it took, and then filter out for the ones that are less than 100 smaller than the solution. So real quick, let's run this against the real input. Okay, so the real input took 9464 to solve. So we want to find things that are 100 picoseconds left. We'd have to go through and solve every possible one until we got 9364. The nice thing is we can stop solving it. Once we hit 9364, we can stop solving it because we know, like, hey, like, you failed. You're not fast enough. But that's not going to be fast enough. It took a little bit to solve it. We could brute force it. I don't think that's what I want to do because I have a couple ideas. Okay. So the first thing is, here's my first idea. If we were to skip this area right here, we know that we skipped all these steps. We need to be able to calculate the number of steps we skipped. And this is going to sound crazy, but I know how to do this. And the reason I know how to do this is because of my childhood. This sounds insane. There's only one path through this maze. It's not even really a maze, it's a trail. When I was growing up, there was a trail by my house, and it was paved and you could walk it, and there were mile markers, but it was also through the woods. So the cool part is, if you were to go through the woods, you'd go off the trail, but then you'd hop back on the trail and you could look at the mile marker and see how much of the trail you skipped by going through the woods. If we put mile markers on every single step here, because what I was saying at first is like, this takes 1 second, this takes 2 seconds, this takes 3 seconds. Put little mile markers there. We know how long the normal path takes. So then if we jump through, Like if we're at, 171 and we end up jumping through the wall here and we get back to 84, we went backwards. If we're at mile marker 171 and we got to 84, we went backwards. So there's no way that will be faster. But if we were at mile marker, 50 and we jump on over here to mile marker 151, then we know that we just shaved off 101 miles. So it's faster. So I think this is the way we need to do it. So what I'll do is, in the old code, we kept track of how many steps we took, and I think that's what we're going to do here, but we can cheat. So the way we can cheat is that we already have this data structure. We already have this data structure called visited, where we just store a Boolean, have we visited here or not? That's all we do. We don't need to store a Boolean now. I think we literally just set it to a flag. We just need to store the number of steps in that we are, which is right here. How many steps it took to get there. So if we do this, I think this will give us our answer. So what we can do now that we get down here, let's see, the maze is solvable. Let's just break out of here, and we're just gonna assert that we solved it, because I mean there's no other way we get here. Maze is solved. If we print the visited, we should know how long each one took. So do we have var dump in here? I'm gonna grab var dump from a different day. I should just make like a shared library that I can pull from. Var dump visited. Okay. So now here are all the blocks we visited and how many steps it took to get to them. So the first block that we visited, the first block that we walked to is 1, 3. So that means 1 over from the right and 3 down to 1, 2, 3. So the first one we visited was our self. It's not quite right. We're off by 1. I think where I moved that logic around, I probably shouldn't have done this. Yep. So now the first place we visited was 1, 2. The next place we visited was 1, 3. That means we're going down. That's not right. Okay, my algorithm's not perfect. I know why. Yeah, I know why. It's not just if it's set. We also need to check that it's lower, because that's what's going to determine if we keep looking. Let me think about this logic. Yeah, 1, 1 took 3 steps. 1, 3 took 2 steps. Yes, that's wrong. It should be 0. Yes, this algorithm's not perfect. I don't understand why it's not perfect, because it shouldn't ever be allowed to backtrack. Maybe we just leave it as breadth. It shouldn't matter. It shouldn't matter which order we go in. Yeah, it should not make a difference what order we go in. Just set 0 to start key, maybe. Yeah, it shouldn't matter what order we go in. Oh yeah, where do I initialize 0? Or steps. I guess I don't even initialize 0. Initialize steps. I keep saying this. Yeah, 1, 3 is spot 0. That's correct. 1, 2. This should be 1, 1. Awesome. And then we should move to the right. So this should be 1, 2 when I type in 3 here. 2 comma 1. No, I was wrong. It should be 2 comma 1. That's correct. That's correct. Okay, I just need to initialize that variable. Yeah, that's ridiculous. I can't believe that was the problem. How fun. Okay. So now we have a list of all the places we visited, all the single coordinates we visited, and we know the numbers. Oh my god, this is going to be easy. I gotta stop saying that. Each shortcut is determined by its start position and its end position. So the wall doesn't matter. It's where we started and where we ended, and we know we have a point value for each one of those points, so we can just literally take the difference. So we just need to calculate now every possible shortcut we could take. How do we enumerate the shortcuts? Well, the shortcuts are the pound signs, and the pound signs need to have periods in their... Yeah, let me think about this. The pound signs need to have periods in at least 2 of their cardinal directions, and we'll try jumping through them. Okay. Yeah, all we have to do is enumerate all the possible shortcuts. So let's think about this. I used to use rows and columns. Your X and Y break my brain. Yeah, I can understand that. I think in terms of 2D games, it's easier for me to think of like that. So how will I enumerate every possible way we can take a shortcut? There's an easy, I mean, it's not an easy way to do it. If we know the coordinate we came from, the coordinate we're going to, then we can look around us for possible shortcuts. Like we could just walk the path that we took and look at blocks around us and figure out if there's a shortcut there. This is one of those problems that's so easy to describe visually and so awful to code. But I think we're getting there. That's not what I wanted. I wonder if it's easier. So my current plan would be to walk here and look around and be like, hey, there's a pound sign here. Maybe check that for shortcuts. No, I think it'd be easier to loop over every pound sign. We just loop over the map, find a pound sign, and then look for all the combinations of points around it. Ah, this sucks. How do I do this? If you're here, because there is a shortcut here, a shortcut here. Okay. I think well, we're just gonna start coding it. Okay, so we're going to check every wall for possible shortcuts. And the way we're going to do this is we're going to loop over the entire thing for walls. Okay, so now we're here. We are looking at a wall. We don't need local. Key is our X comma Y. There's like 16 possible things with overlaps. We could break them all. I'm thinking about just breaking them all down, like unrolling whatever for loop would cause us to do this, because we just need to check them in possible directions. Yeah, I think we're going to do it that way. So the way we'll do that is we'll say next X equals X1. This will be the starting X and the end X. So starting X will be the X to the left. End X will be the X to the right. Starting Y will be Y. ending y will be y. So this will check, if we're at a wall, we're going to check the west of us, and we're going to check the east of us, and we're going to see if they're both periods. If they're both periods, then we can, then we can try seeing what those look like. All right. It's kind of scuffed. By using the visited score. SX, SY, and X, and Y, dash N num1, and dash N num2, or continue. They both have to be set. Now we need to check the difference. If num2 is greater than num1, greater than num1 plus 100, then this shortcut is viable. Okay, so that is how we will tackle this. And when the shortcut is viable, we will store all possible viabilities in a shortcuts array. So we'll do shortcuts plus equal whatever that difference is, right? We'll figure that out later. Shortcuts plus equal the distance that we shave off? No. Once we get down here, the steps, let's call it distance. That's the distance of the maze after we've solved it once. So now the shortcut is the difference. So let's do this. Diff equals num2 minus num1. Diff less than or equal to 0, meaning it doesn't shave off any time, which is impossible, or it's negative. Then we continue, because we don't want to go negatively. If the difference is greater than or equal to 100, then we add that to the list of shortcuts. I think we maybe want to use an associative array here, but we shall see. Andy says, hey man, just stopping to say great series, inspiring me to brush up on my bash. Good stuff. Yo, appreciate it. Thank you for stopping by. Yeah, heck yeah. I love hearing that. That's so cool. You'll need a list of the best cheats. How many cheats would save you at least 100 picoseconds? Oh, okay, cool. So we really just need to increment a counter here. We're just pushing to an array, but we can just count the length of the array then. I don't really care. Found valid shortcuts. Cool. Okay. Check all spots around us. Let's make a quick little function called check shortcut. And this will take two keys. Key 1 and key 2. Okay. And then we can put all this into a function. There we go. Okay, cool. So now we have that, so we can just do check shortcut sx sy ex ey, and this will check one of the possible shortcuts that we need to check. Ey. Okay, check all the spots around us for a shortcut. So that means check west to east. The nice thing is if we're checking west to east, we don't need to check east to west because we'll check it on the way around. So if one of them's backwards, the other one won't be backwards, which is pretty cool. We do need to filter out. Yes, we do need to filter out them by key. That's what we need to do. So this does have to be an associative array, where the unique key is key 1, key 2. That's because there's a start and an end. So we do have to do this now that I think about it. There we go. So now we can just loop. Yeah, we still loop over it and it's just fine. Okay, this is fine. Okay. So we checked west to east. Let's check west to... Let's do this. Let's move this up here. Let's check north to west. We'll check all the norths. So in order to check that, this should just be an X. North is... North is Y minus 1. Okay. And west is X minus 1. Okay. Check north to east. This will be X plus 1. And then check north to south is Y plus 1. Okay, so we got those down. And we don't need to check north to north. That doesn't make any sense. And if we check north to west, this, we just need to check west to east, south to west, and south to east. Okay. I think this is all possible combinations. And south would just be plus and plus. Okay. We're not checking the diagonals. We're checking the ways they connect through a wall. So we're looking at a wall and we're looking up, down, left, and right from that wall and then connecting them all. So if we can go up and to the left, we check those two. We check that we can form a shortcut through it, is what I'm trying to say. I think we're okay. Let's just var dump this one. Yeah. Where do I call continue outside of a loop? Oh, yeah. Okay. Found 0 failed shortcuts. Let's make this logic better. Cool, so we made it there. Okay, so we're looping over all the walls that we found. Nice. And then we're looking for valid shortcuts. So let's go ahead, check one shortcut, and then exit one there. So in order to check a shortcut, we do this. Cool. Key 1 equals 0, -1. Key 2 equals 0, -2. Okay, so that should just fail. Okay. Num1 and num2 should be using... Hold on. I'm still problem solving. I'll get there. This is right. Let's just check the first row of them. Yeah, num1 and num2 never get set, so they should be getting set at some point. Yeah, that's it. Okay. Still found 0 valid shortcuts, but it looks better. Oh, we never store the shortcuts if they're less than 100. Yeah, let's just store them for now. Then we can filter them out later. Oh, okay. Yeah. So here's what each one stores. So what we can do, we can reverse this. So for key in shortcuts, do done declare -a output okay. So this, the key is this, we don't care about. We care about just the value, which is the number. We'll store that in count. We'll do count at value plus plus, and then we can var dump count. There we go. Okay. So let's see. I'm looking at the final output. There are 14 cheats that save 2 picoseconds. According to this, there are 16 that save 2. Yeah, because this is the cheat, and this is how many picoseconds it saves. I don't think this number is right. Let me think about this. Let me do some braining here. North to west, north to east, north to south, west to east, south to west, southeast. Okay, that's all right. We circumvented 4 blocks. Well, we skipped 4 blocks. Let me think. If we skip some blocks, we still have to go through the wall. So there could be like an off by 1 thing going on here. We'll just keep that in mind for later. This is how many picoseconds they save, and this is how many things could do it. So according to this, there's 1 cheat that saves 64 picoseconds. We don't even have one that saves 64. Yeah, we've already done shortcuts. Yeah. Yeah, these all look fine. We take the difference, filter out any ones that are below 0, because that would be putting us negatively. Are you sure the start and end of your cheats are correct? No, I'm not sure of that. Yeah, why does this one say 40? Oh, there is one that saves 40. There's one that saves 38. Wait, these are right. There's one that saves 40. There's one that saves 38. Should be one that saves 36. I don't see that there. This should work. For my shortcut, let's do a verbose bar dump. Let's get the length of the amount of shortcuts. So according to this, we had 45 shortcuts. This example doesn't tell us how many there are. We'd have to add it up ourselves. We have 45. Okay, so what it has is 14 sheets plus 14 sheets plus 2 plus 4 plus 2 plus 3 plus 1, 2, 3, 4, 5. 44. Okay. So there's supposed to be 44 viable cheats. We have 45, and our numbers are wrong. Okay. Not the end of the world. We're definitely missing this one that gives us 64. And there are 14 cheats that save 2 picoseconds. There are 14 cheats that save 4 picoseconds. Wait, I think I have it backwards. This is how many picoseconds they save. So this is how many picoseconds they saved. Okay. So 2 here should be 14 and it's 16. 4 here should be 14 and it's 9. Yeah, so things are just off. You told a great story from your youth and overcomplicated it. Yeah. We'll see. I'm wondering if my numbers are wrong. Like once we solve the maze. I have an idea. Let's do a print grid here and exit. Let's just make sure my maze looks good. So we have the maze here. What we can do is, how long did it take to solve? It's like 84. Okay, so what we can do, that's a 2-digit number, is we can do this. Every wall will replace with 2 walls. Every period will replace with 2 periods. Yeah, I got an idea. So we just need to pad this. super ugly, but we're going to see if this works. I'm going to print out the number of steps it took, and we're going to double the whole thing. Okay, here's what the maze looks like. That from boxes, task, flashbacks. Yeah, it's very similar to the boxes task. We're doubling the maze, and the reason I did this is so I could fit all the numbers in, so we can look at the distance that the mazes actually take up. This is a really cool way of visualizing, isn't it? Wow, that's a neat way of visualizing it. Go me. We never store the end distance. Oh, that would make sense. If we don't store the end distance, then, yeah. If we don't store the end distance, then we'll never get that one that saved a ton of time. Yeah, because we check if we won before we check if we visited it. So let's swap those around. Yeah, visualizing stuff really does help. Cool, so now we have an end distance of 84. So we know all these beautiful distances, and we're checking all the things. If we go from 4 to 10, we say that we've skipped 6 boxes. So we have to take 1 step, 2 step. It takes 2 steps to get there, whereas it would have taken 1, 2, 3, 4, 5, 6. It would have taken 6. It took us 2. I think we need to add 2 back in because it takes time to actually go through the wall that we clipped through. So where we get that difference, I think we need to subtract 2 from it. It says took 85 steps. That's incorrect. It took 84. Yeah, let's only do distance plus plus if we haven't won. Took 84 steps. Okay. So now we have that. We try all the shortcuts. We have a length of 29. That's not right. That should be 45. The visualization is neat, but it won't work on the real output because it would be longer than 2 digits. Absolutely. That's correct. 100% it will not work. This is just to get the example working. But yeah, it would totally break. I'd have to figure out the max width of it or come up with characters to represent it or something. So we found 29 valid shortcuts. That is very incorrect. We should be finding 45, which scares me because we had 44 before. 1 3 to 3 3. Saves 4. That's correct. I mean, that's correct. Like, we're correctly identifying some of these. We still don't have the one that saves 64. Where is the end location? End location is 5 7. Okay. Yeah, this one saves so many steps. 84 minus 18. That one saves 64 steps, which is the right thing. That's what we're looking for. Also, when you moved around the code, did it jump from 84 steps to 85? It did, and then I had to move the plus plus. So basically we have to record if we won before we increment the number. So it's 84 now. So yeah, that correctly identifies a shortcut at 64. Let's go ahead and do this. Let's grep for, give me some crazy context around this for num1 equals 84, num2 equals 18. Okay, so here it is. And the context here is we check shortcut. So it did not consider that shortcut to be valid. Here's the interesting thing. That one's not coming up. We're not checking it backwards. Why are we not checking it backwards? Yeah, because we checked if we could jump over west to east. Yeah, we have to try all directions. We do, don't we? Yeah. Because I'm thinking about this like paths, but they're not paths. What we have to do here. We should just try it. We should try all directions, but we could just reverse them. Yeah. Yeah, if it's reversed. Let me think about this. Take the absolute value, and then we'll subtract 2 from it. If it's less than 0, somehow, shouldn't be. Breakout. Otherwise, the valid shortcut. Okay, we do have some minuses in there. That's not, oh, because we're still using diff. $77. I guess we don't want to keep the ones that are zeros. We filter them out. Oh, less than equals 0. 44. Is that right? Is that the number we got? 44. Okay. Okay. You're checking all directions. It has to appear anyways. Diff was correct. Seems bug somewhere else. I don't think that's correct. I think the bug was here. I wasn't checking all directions. I was only checking all connections. If I was checking west to east, I wasn't then checking east to west. The way I got around that was by knowing if you reverse one of the... If you jump west to east and it's negative, then east to west is the positive one. So that's what I did. So I just reversed it there. So instead of making all possible locations, I just made all possible combinations or connections. So I think this is right. So there should be 1 with 64. Yep. There should be 1 with 40. Yep. Should be 1 with 38. Yep. Okay. 1 with 36. Awesome. 1 with 20. Nice. There's 14 with 2 and 4. Hey. I think we're good. 2 with 6. Yep. 4 should be... Or sorry, 8 should be 4. Yep. 12 should be 3. There we go. Perfect. Drum roll, please. Yeah, exactly. It's gonna print a lot. We might have to remove some prints. Let's just get an idea of what the real input actually looks like when we run it. Yeah, we might have to remove some of these. No, okay. That was fine. Oh, we didn't do the right work. We need a list of the best cheats. How many cheats would save you at least 100 picoseconds? That's what we need. So we need all the keys that are greater than 100, and we need to sum them all together. Yeah. So all the keys that are greater than 100. Yeah, the value is... Okay. Yeah, so if value is greater than equal 100, because it's at least, then total equals 0. Total plus plus. Oh my god. Found total valid shortcuts. Okay. 1367. Drum roll. Let's go. Let's go. Nailed it. That's the right answer. You are one gold star closer to finding the chief historian. What's up? What's up? What a wild solution. Oh my god. What a wild solution. Boom. That's incredible. Nailed it. Whew. We're doing all right, everybody. Let's go. Let's absolutely go. Man, you rock. Heck yeah, man. We nailed it. GG. Thank you. Thank you. What do y'all say? Part 2? I mean, we're on a roll, right? I think we have to. Oh, man. Yeah, I think we have to. Let's do this. Part 2. The program seemed perplexed by your list of cheats. Apparently, the 2 picosecond cheating rule was deprecated several milliseconds ago. Oh, no. The latest version of cheating rule permits a single cheat that instead lasts at most 20 picoseconds? Oh. I can't think about this right now. Yo Hans, thank you for the 100 bits. Heck yeah. Now, in addition to all the cheats that were possible in just 2 picoseconds, many more cheats are possible. This 6 picosecond cheat saves 76 picoseconds. I don't know how we're going to do this. Because this cheat has the same start and end position as the one above, it's the same cheat, even though the path taken during the cheat is different. Right, that's what we learned. Cheats don't need to use all 20 picoseconds. Cheats can last any amount of time up to and including 20 picoseconds, but still can only end when the program is on normal track. Okay, so I can clip through 19 walls. Any cheat time not used is lost. It can't be saved for another cheat later. You'll still need a list of the best cheats, but now there are even more to choose between. Here are the quantities of cheats in the example that save 50 picoseconds or more. Oh, and they don't even tell you, like, how many, because it's the start and end that is all that matters. Find the best cheats using the updated cheating rules. How many cheats would save at least 100 picoseconds? Oh, boys, this is going to be rough. So, I've been doing some thinking about this puzzle. And I think, GG, we're screwed. I have no idea how to do this. All right, so they can cheat up to 20 picoseconds. Before they could cheat for 2 picoseconds, which allowed them to go through 1 wall. Now they could go through 19 walls, or they could go through, for 19 seconds, they could disable collision, and they just disable collision, right? So technically in those 20 picoseconds, it could be like wall, trail, wall, trail, wall, trail. As long as they land on a trail at the end, I think they're good. Let's see. because it has the same start and end positions as the one above, it's the same cheat, even though the path taken during the cheat. Yeah, the second example shows it. Yeah. Yeah, so they can, okay. They just turn their collision on and off. And if they turn it on or off, they can stay in that state for 20 seconds, 20 picoseconds. It'll be lost, yeah. So they have an ability that can activate once that lasts for 20 seconds, and they can cancel at any time. But as long as once it's up or when they cancel it, they need to be not phased through a wall. Okay. I have a hint locked and loaded. Well, thank you, but not right now. But yeah, that's awesome. You'll still need a list of the best cheats, but now there are even more to choose between. Here are the quantities of cheats in this example that save 50 picoseconds or more. Although it hasn't changed, you can still get your puzzle input. Cute. Okay. How do I want to do this? I'm trying to think of the variables we have. We have the path, the walls, the number of time we can just phase. Because obviously brute force isn't the way to do this. It's not like, you know, I pick a position. I walk through the maze, and every single step, I imagine if I phased for 0 through 19 times, and where I could possibly end up. Like, that sucks. That sucks. Let me think about this. All these puzzles are just data representation problems. If I could just think about how to represent the data in a different way. Now, technically speaking, this sucks, because I could just enable, I could just, Yeah, because, like, I could move up, enable phasing here, and then start moving right back down the path I was just in. And that would save time. Do you have to phase through a wall? Do you have to be in a wall? Because, like, hear me out. I walk up one space, I enable phasing mode. Or I walk up 2 spaces, I enable phasing mode, and I instantly walk back down. So I'm not walking through walls, I'm walking through places I can walk, but I just have the collision off, and then I make it here. That's slower than a cheat would be, but faster than taking the main path. Like, that would have to count, right? Yeah, because, like, literally, like, just because you enable the cheat doesn't mean you have to walk through a wall. Yeah, because right here, like, I know that's a free space. This is a free space. Cheat stops when you back to the track? I mean, no. Because this is back on track, and the cheat's still going. And I understand that if I were to turn on phasing mode and then just walk the track normally, I'm not going to be better than 100 picoseconds. Like, I get that much. Cannot revisit a path you've already been on. It doesn't say that. I put that in there to do the path solving algorithm, but I don't think this puzzle tells you anywhere that you can't backtrack. Like, technically speaking, you could be able to. Now, obviously, it's not the fastest way, but it's faster than not cheating. I don't think there's anywhere that says you can't backtrack in this. That's what I'm worried about. It seems like there's just too many possibilities here. Yeah, because the start position is just the first move that is allowed to go through walls. Allowed that goes through walls. So, like, you know, I could turn it on here, walk up, and then walk back down. Oh, but then that's the start position. Start position and end position are how we uniquely identify cheat. But I could walk my way up here, turn it on, and then walk back down. My start position is here, my end position is down there. Yeah, so this is what I'm worried about. Like, it's just there's so many possibilities here, which means I need to find a different way to represent this. Like, yeah, from each start position. Like, okay, I could calculate. This is not this. I don't think this is the way to do it. From each start position, I could just start calculating. I could just start branching out here, here, here. I could phase to everything around it. I could branch out 20 in all directions from 0 to 20 in every possible direction, calculate the start and end, calculate the difference, and then see if it's viable. But I feel like how long that would take, I don't know how long it would take, but it would be large. It'd be a large amount of time. Because you have to figure out where you could end up, and I don't know. I think that algorithm works. I think we just walk the path, and then like we find every single period on this, and then we just branch out 20 in every possible direction. So, you know, like up 20 over 0, up 19 over 1, up 18, like, you know. Would it take too long? That's the thing, Dark Space. I don't know. Because here's the thing. I don't actually think it would. Now, okay, hold on. It may take too long for Bash. I don't actually know. You won't know if you don't try. Well, that's very true. Oh, man. That's what I'm thinking. Yeah, for every dot, that's my start position. Just reach out as far as I can possibly reach from 0 to 20 and check, oh, did I hit a dot? And have I not checked this dot before? Then, yeah, I'm basically drawing a circle around it. And for the sake of this exercise, I could literally just do 20 up, 20 down, 20 right, 20 left. No, I couldn't do that. I have to be able to reach it. I would go to one of those Minecraft circle generators and draw a 40 by 40 circle. I'm not going to do that. Or maybe. But, rotated square. Is that what it's called when you take a circle and you just force it into a two-dimensional plane? Yeah, I'm thinking about this. Yeah, the original passive count. Couldn't you use that information there down? Yeah, you can. Because it's only 100 picosecond difference. So, like, I can limit the domain of things I have to check. I don't need, out of the, 8 million spaces I have, I only need to check 7,900,000 of them. You know what I mean? Like, I don't think that's going to save me too much. Actually, wait, what was it? Let's see if I remember how to do this. W count -L capital L. And then if I do the real input, we're dealing with, 140 by 140. So 140 times 140. At that point, saving the 100 is not going to be huge, but Yeah, that domain's already pretty large. But I'm just trying to think, because I'm just imagining like we just branch out into every possible thing. And then we calculate the distance. We have the distance. I think this might be the algorithm. I think this is where I implement the algorithm, and then we just see. So let me think about how we could validly get to everything around it. Let me think about this, because we could go 20 up, go 20 down, 20 right, and 20 left, and then we just have to draw the circle around it. So how do you represent that circle? That's like, that's going to be the hardest part. I'm coming up with the ugliest ways in my head to do this. This is not how I want to do it. It sounds like a job for threads. It might be. This might be something that we thread out where we can call this program with a position to check. But we just have to see how fast this can do it. Yeah, I just need to... I have to figure out how to loop over a rotated square. And I don't think that's going to be too difficult. That's just a math thing. Let's try and figure this out together. If we have, I don't know. If we have a puzzle that looks like this, like, and we have like, this is where we want to start. No, it's not going to be that way. That's not going to be that way. It's going to be like this. Yeah, because it would take 2 steps to get there. 2. This would be 3. Oh, yeah. I've seen this design before. I don't know what it's called, but I've seen this before. Yeah, I've seen this. I'm going to keep saying that. I've seen this. I've seen this. I'm looking at it right now. You've all seen it now. We've all seen this. I'm at the part of the night where I'm going crazy. All right, so. We have this. Yeah, so if we wanted to branch out 2 in each direction, we can go up here, but we can't go left or right. We can do 2 in this direction, 5 in this direction, 3. Let's try and figure out a way to do this. Our starting point is x equal 2, y equal 2, which is this spot right here. Our puzzle input is this. How would we do this? I think it might be worth getting this logic down. Yeah, it's going to be worth getting this logic down. So what we'll do is we'll vim cp square to simple.text, vim simple.text. Okay. cp part 1 to square, vim square, and then we will read it back in. Okay, then we just read the maze. There's nothing we need to do here. We just store exactly what's in there. Cool. So now if we run square and we run it against you CP over it, you don't keep the permissions when you do that? It's interesting. Okay. So we have this basic thing that reads in the file that we're looking at, and we need to figure out a way to loop over the 0, 1, and 2. Can I do this? Yeah, so we need the 0, the 1, and the 2. So let's figure out how to write that logic. radius equals 2. We need to branch out of a radius 2. So the way we do that is we start 2 above the y. We start 2 to the left of the x. We don't start 2 to the left of the x. We work our way to 2 to the left of the x. Okay, that's fine. Oh, HL is neat. Yeah, HL is awesome. It's I call it highlight. It's an alias for RG, which is rip grep, the Rust rewrite of grep, with a dash dash pass through option. So I can just pipe HL, what I'm searching for, and it just highlights it. It doesn't filter it out, which is nice. Super useful. So if we want to look at a radius of 2, we need to go for y equals minus radius. Can you just do that? Okay, that works. So now we got the y coordinate of where we need to be. Now we need to calculate all the x coordinates. So the x coordinate for here would literally just be x equals radius x less than equal radius x plus plus. And what goes in radius for both those things is what needs to change. What did I print wrong? Yeah, definitely a typo. I could see that. Just from the output, I was like, that. There's nothing right about that. Okay. Yeah, because negatives are not going to be in there. Oh, right. We have a starting x and y that I set somewhere. Yeah. We have a radius of 2, start x equals 2, start y equals 2. So these are the places we're going to start at. So it would be start x minus radius. Y is less than or equal to start x plus radius. We also need to do bounds checking. That's fine. We'll get that for free. Let's just see what we have here. Okay, well, we're getting some of them, which is good. We might have an off by one thing. We'll figure it out as we go along. X equals start x plus radius, start x minus radius. Let's change these to y. Okay, so this did everything. So we want to check if yeah, our start y is our base, and our radius is how far above we are. Distance equals is the start y minus y. That's our distance, okay. And that will determine how many x's we look at. That's the difference. We need the dist, which is the absolute value. And how many we'll look at will depend on that, because that's how far away we are. When we're at the 0th spot, we'll look at the max. I think we just subtract the difference. Something. Because when we're here, we want to look at 5. The radius is 2. 2 times 2 plus 1. Two times 1 plus 1. 2 times 0 plus 1. Yeah. Radius times diff plus 1. Yeah, we want to look at 5, 3, 1, 3, 5. That's what we want. That's how many of them we want. Oh my god. Okay. Well, that's how many we want to look at. How do we translate this for loop to represent that? Oh, and we want on the opposite. We actually... Yeah. Yeah, we want to subtract 0, we want to subtract 2, we want to subtract 4. Yeah, okay. We're getting there. Oh my god, I got it. This is it. Well, that's a weird way of looking at it, but yeah. I would like a better way of representing this. You know what we could do? We can just set it. We can just, for our demonstration purposes, we can just say grid x comma y equals a space, and we'll delete them from the grid. That looks good. Yeah, space is hard to read. Okay, we got it. So now we have a point. We can check all of these points around it. So if we're allowed to phase for 1 picosecond... No, we're allowed to phase for 2 picoseconds. This is right. This is right. So 2 would get us up here. 20 is what we want. This is the logic. We have the logic now. Okay. Oh my god, this sucks. All right. Now we have the logic to do this. So to do this, what are we going to do? We're going to CP part 1 to part 2, Vim part 2, and try and remember what we were doing. I don't think printing the grid will ever be useful, but I'm not going to get rid of this. Okay. Then we read the maze. Nice, nice, nice. We solve the maze. Nice, nice, nice. This doesn't take too long, luckily. Luckily, this logic all works really good. And then all of our check shortcut stuff needs to change. So I'll go ahead and trash all this, because we'll just rewrite it. Check every wall for possible shortcuts? No. Check every step for possible shortcuts. And the way we know our steps is because they're in our visited. Yes, it's one of the keys. We have to loop over every single key we've ever visited. Yeah, that's what we have to do. For key in visited. Let's run part 2 on our example. Why are we not? Oh, we're not looping keys. That makes sense. There we go. This is every step. So once we have a step, then we need to run that crazy algorithm on it. Okay. So find every, I don't know, check every shortcut, call it. We'll grab the logic that we wrote in Square. Also, what's up, YouTube chat? What's up, Twitch chat? You guys still here? You guys still hanging out with me? I assume so. I assume everyone's just vibing. Here's the Square logic. A radius, a start X, and a start Y. Okay. Yeah, what's up, NMBB? Heck yeah. Love it. Cool. So our radius, it's not 2. It's 20. Start key is $1. And then read IFS equal comma read dash R start X start Y from the start key. Dark space is not there. Good. Cool. He's left a very dark space where he once was. Yo, what's up, Andre? How you doing, man? Present. Remember, you can pipe to sort dash cap v on your print visited to pretty print. Hey, I do have to remember that one. I remember the word count one, so I'm learning slowly. Takes a long time to teach this dog some tricks. We don't want to do this. Generate every possible stopping spot. Okay. So now we will pull this character out of the grid. End key will be X, comma, Y. This will check itself. Yeah, that's annoying. If end key equal start key, then continue elif if the character is empty or the character equals a wall, then there's nothing we can do. If we were down here, this is a valid ghost move. This is a valid move. Check it. Cool. So now that we know it was valid, we need to check it. And the way we check it is we get the num1 and the num2. Okay, cool. Let me go grab this from part 1. Because now we're going to check the shortcut. And we don't need to do this, like, difference thing. We don't want to do this. Because we're going to check every part of the path, so we will check the reverse of everything. So we just need to remember that. Where did we set it? We set shortcuts? Yeah, so we should probably, you know, declare dash cap a shortcuts. Cool. Check every shortcut at the start key. Check every shortcut at the start key. Okay, so we loop over every single one of these. This is a valid move. We check if we visited. We get the difference between the two. We subtract 2 from it. If it's less than or equal to 0, we do that. Otherwise, we store it. And we also want to throw it out. Okay, yeah. If -z shortcuts. Oh yeah, here's what we'll do. Existing equals shortcuts at key. We need to check if one already exists there, if we got there in a shorter way. Otherwise, we'll default it to very large. If dist is less than existing, then we will store it. I don't think it actually matters. I think we just need to look at the number of them. Var dump shortcuts. Part 2, read in from example input. Bad array subscript. Nice. Oh, we have key 1 and key 2, and we have start key and end key. Yeah, let's just be consistent. That can't be right. Is that right? Okay. Okay, we're doing work. We're doing work very fast, which is nice. How are none of those shortcuts valid? Oh, I didn't need this. Diff is num2 minus num1. Diff minus equal 2. We just subtract 2 from it, okay? If diff is less than 0, then we return. Yeah, that should be a continue. Okay. Okay. What do we need for part 2? But now there are even more to choose between. Here are the quantities of cheats in this example that say 50 picoseconds or more. Okay, let's grab the ones that are above 50. I think we're just like there. Is that? I really thought that would be so much slower than it was. You have another return in there. I'm not sure if it ever triggers. Hey, thank you. I do. That is good to know. For key in shortcuts. If value is greater than equal to, we need 50 for this example. Found 0 valid shortcuts. Well, that's not right. Why are we saving some shortcuts that are 0 too? Well. Help if we use the right names. 561 valid shortcuts. I have no idea if this is 561. I'll show you. This doesn't tell me if there's 561 here. It just gives me numbers for all of them. So how about we take this input, we bring it to the terminal, we call it foo.text, paste it in there, cat foo.text, grab the third field, total it up, 285. Okay, so if we're saving 50 seconds or more, or 50 picoseconds or more, we need 285 from that, and we get a lot more than that. Field total, are those more aliases? Yes, they are. I have them somewhere on my GitHub. I don't remember where. Field is just a very simple wraparound awk that just grabs whatever field you give it. So I can say like field 3, and then I can optionally give it a field separator. So I can say like field 2, comma, and it will just like, see, like, you know, echo foo bar baz, pipe it to field 2, comma. It'll grab the second field separated by commas. And then total is just another awk that just literally goes through and sums it up. It assumes you give it numbers, I think, and then grabs the first field. So I think I can, yeah, I can also do the same thing there too. I think I can do like total field 4 broken by hyphens. I think I could do something like that. So yeah, totally useful. Feel free to steal those. Okay. Yeah, feel free to take them. I don't love... What am I viewing? What am I looking at? We have an associative array that associates what to what. Were there 82 shortcuts that saved 1 picosecond? Is that what it's telling me? What is the value here? Shortcuts is the key to the diff, which is how much it's saved. Okay, so the value is how much it's saved. If the value is greater than or equal to 50, then we only store it in the count. Okay. Yeah, so the key should only ever be above 50. No, we store them no matter what. That's what we're doing. We have 33. There are 285 over it. We have 561. That's suspiciously like almost double. It's like suspiciously almost double. I wonder if we're just like double recording them, but we shouldn't be. All right, so let's look at this. There should be 3 cheats that save 76. So let's look at above 75. Yeah, see, this is wrong. You have way more amount of cheats that do that. Might just have to trace the code. We know we solved the maze just fine. We've already used that logic. For key in every single place that we have visited. Do we count the first place we visited? We did. We check every shortcut of that key. So we branch off on the path and check every single shortcut. We have a radius of 20, the input key, start X and start. We initialize these to 2 for some reason. We shouldn't. Doesn't matter. They get overwritten down here. We get the start X and start Y. Start X, or start Y minus radius, start Y plus radius, Y plus plus. Yep. We have the diff and the distance. We are overwriting diff. I don't think that matters. Yeah, I don't think this matters, but let's just rule that out. Do you have to skip any that you already checked? No, because I won't save them. When I save them, I actually check if we already had something in that spot. I grab the existing shortcut at that key and name it existing, and I default it to like a really big number. And then we check if the one that we found is less than the one that we're doing. Less than. Less than. We want it to be greater than. Well, now we found 36 valid shortcuts. It's not right. But yeah, okay, so something funky's going on here. Have you declared existing as an associative array? No, existing is not an associative array. Existing is, this is just a variable. That's I'm pulling this key out of the associated or associative array. So I'm just a variable I'm declaring here. You changed the total value threshold. I know. It's all good. It's all good, man. Don't worry about it. Yeah, no, I changed the value threshold to be 75, and according to my example over here, there should only be 3 cheats that are 76. So I should just be filtering out. Only 3 cheats should match this. So I'm trying to just, get 3. And unfortunately, I'm getting 36. And according to this, there's 7 that match it. So what I should probably do is I should probably look and see what matches 76. Okay, so here are all the cheats that match 76. 1 to 2 to 2 to 9. This doesn't seem right. I guess we could look for the ones that were like way higher, right? Didn't something like save like 84? Yeah, 1 to 3 to 5 to 7. 1, 3 is here. 5, 7. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Yeah, if we go from here and we go there, that save 82 picoseconds. Yeah, see, right. Wait, yeah, no, this is right. It takes 84 to solve this. So I'm doing something wrong. It takes 84 steps to solve this thing. If we turn on our cheats here, and then we get down here, we've saved 82 steps. Hold on. we're subtracting 2 because of the number of steps we've taken. We subtracted 2 because of the number of steps we've taken. That made sense when we were only branching out 2 steps. In this, we're branching out anywhere between, like 0 and 20 or whatever. This number is the problem. This needs to be configurable. We have to figure out our distance now. When we are here, how far away from me are the center? What is our distance to the center? And that is the absolute value of the x plus the absolute value of the y. Now we have the absolute value of the x and the absolute value of the y. So if they have a distance of 0, 0, that's 0 steps. That's looking better. Yeah, this is looking way better. 3 valid shortcut 76. Hey. Spend some time to figure out that x and y need absolute value. Yeah, I unfortunately do the opposite. I jump to that quicker than I probably should. This is looking good. So if we change this down to 74, we should have 7 cheats that are valid. 7 valid. Yeah, 4 and 3. Okay, I think we got this. And if we change this to 50, we should have... what was that thing that we said? If we total it up, we got 285. This should be 285 at the bottom. 285. That's it. That was the problem. We're going to get it. Hopefully we're going to get it. We have to change it. I have it set to 75. It needs to be set to 100. I have it set to 50. This needs to be set to 100. Let's go ahead and read it in with the real input. And fingers crossed. Fingers crossed. It might be too... I don't know if I have to get rid of those recordings. I don't know if that's too many echoes. It's probably slowing it down. It's 100 for part 2. Yeah, finding the best cheat using updated rules. How many cheats would you say would save you at least 100? I'm going to stop this. Still leave some prints in there, but, And let's, let's make our lives even easier. Oh, wait, I didn't even print the link, didn't I? Yeah, there we go. Okay. So we just have to check 9465. Oh, yeah, this is totally doable in, like, a reasonable amount of time. Yeah, it's not exponential this time. Yeah. Yeah, it's 50 on the sample and 100 on the real input. It's kind of weird. Yeah, look at that. We're already at 1,000 out of 9,000. We're going to get there. We need a no echo emote. Oh, that's so perfect. Oh my god, yes. Let me write that down. That's a really good idea. That's really perfect. Oh my god, look at this. This is so easy. Oh my god, we're more than a quarter of the way there. Oh my god, we're a third of the way there. Yeah. I do find it a little bit annoying when they're different between the real input or whatever. But yeah, it's not the end of the world. It is what it is. But yeah, it's super clean when you can just pass in different pieces of input and then gather all you need to solve the test just from the input alone. I think that's pretty cool. Hey, now would be a good time to remind everyone, if you're on YouTube, go ahead and hit the subscribe button. If you're on Twitch, go ahead and follow me, yada, yada, yada. I have a pretty cool website. I have a bunch of socials. Go ahead and hit !socials in the chat and it'll work. Or you can do !YSAP for You Suck at Programming. You know, I'll go ahead and do it for you guys. No, I'm just kidding. You guys do it. !YSAP and you'll get you can see my website there. It'll give you a link to it. Nothing stopping you from running this in threads, right? Does one test depend on the other? No. Well, you could run this in threads. You could absolutely run this in threads. You would have to just write out, like, say you threaded, Vardump's going to take a while. Let's wait for this to finish. Man, printing the screen really is costly, isn't it? Don't we print another thing to the screen, too? Probably should have removed a bunch of this stuff. Did I not print at the bottom of the screen? Oh, God. We have to go find the answer? Oh, this is super cool. This is awesome. There's nothing stopping you from using threads. If we were to do it with Bash or something, okay, we have the number here. You could technically get... Let me think about this. No, yeah, you wouldn't even have to do any sort of, you wouldn't have to do any sort of, like, locking or anything, because each thread would be given a unique start position. That's what I'm imagining, and it would just branch out 20 in all directions. So because it has a unique start position, that's part of the unique key. So if you were to cache the data, you could just cache it like that in some shared data structure. If you were in Bash, you could just write it to a file with, start key hyphen end key, and you could just go right there and how many numbers, and then just sum them all later. Yeah, this could absolutely be threaded. Wouldn't either merge the results of each thread, really process, since they don't really share memory, but it's certainly doable. Yeah, exactly. Yeah. So if I were to do this in threads, I would absolutely, I would write them to files, and the file would just be the name of the start key, hyphen the name of the end key or something. As long as, they're all file system save characters, no slashes in them. But if you did that, they would never interfere with each other, and then you would just need something to go through and sum them all up at the end. Or, process them at the end. Okay, we got a big number here. Let's go ahead and check it out. Check it out. I'm going insane. I have been doing this for too long. Submit. Let's go. Let's go. Let's go. That's what I like to see. That's right. First try, baby. That's the right answer. You are one gold star closer to finding the chief historian. What's up? 40 stars. 40 stars. 5 more to go. Killed it. Nailed it. Absolutely destroyed it. Nailed it. Absolutely nailed it. Let's go. Whew. Awesome. Attaboy. That was fun. Ha ha ha. Hey. Whew. That was a good one. That was a fun puzzle. I enjoyed that one. Really good difficulty. I liked it. It was a little bit straightforward, and then it wasn't, and then it was. It's so funny. I came up with the... Thank you, Darkspace, for having me not second guess myself. I came up with the algorithm, and I was like, that's going to be too slow, right? And then it's like, wait, no, that is how you would do it. It's so crazy how it's just so different than that first algorithm I came up with. I was like, let's search the walls. Now it's like, no, let's search the path. Which is nice. The path is bounded. The walls are theoretically infinite. So let's see. Yo, Andre in the YouTube chat with the $3 super chat. Thank you so much. That is so nice. Oh, man, that's why I'm doing these puzzles, because I know Andre's going to super chat. No, I'm kidding. But, yo, I appreciate it, man. That's awesome. Knew you would nail it. Thank you.